Hi, Kate here. So I'm going to go over the Michaelis equation and derive it for you. So to start out, we have E plus S, and then a backward and forward reaction goes to ES. So I have that here. And then what's important to know is K2, we have ES goes to EP, or E plus P, I forgot the plus. Okay. And then we have the instantaneous rate of reaction of ES, and then that's where we get the dES over dt equals K1 ES minus K negative 1 ES minus K2 ES, and that actually all equals 0, so it all ends up canceling out. So this is what that equation is. So now we can use our E total equation. So that's equation number 4. So I have all the equations that were on our sheet right up here, so we can refer to them. So we have equation number 4 right there. So we have E total equals ET plus ES. And then what we really want is what ES equals, or E equals. So we're just going to use some algebra, and we're actually going to move everything around a little bit. So then when we do that, we get E equals ET, or E total, minus ES. So we have our new equation down here, E equals ET minus ES. So now we can plug that new equation in, the E total minus ES, into our original instantaneous rate reaction. So now I will write it all out. dES over dt equals K1, and now is where I'm going to put that new equation. So I have E total minus ES, and then I have that S on the other side, minus K negative 1 ES minus K2 ES. And I'm going to put a big circle around what I just added. Alright, so there's the big circle. I added our new equation right here, right there, which is where E originally was. So now I'll do the distributive property and distribute that K1 on over and make a new equation. So now I have K1 ETS minus K1 S minus K negative 1 ES minus K2 ES. Alrighty, so there is my new equation down there. Sorry, I'm figuring out this camera. And now I'm actually going to move the ES over to one side to get everything a little bit more organized. So I have ES and then parentheses K1 S plus K negative 1 plus K2 equals K1 E total S. Alright, so there's my new equation right here when I got ES over by itself on the other side. And now I want it even more by itself, so I'm going to do some division to get rid of it. So I have ES over here on the one side of the equal sign, and I do K1 times E total. And then let me move the S over. K1 is now underneath is now in the denominator. S plus K1 plus K2, and I'm going to multiply it by 1 over K1 over 1 over K1. I'm running out of room. So there is my new equation, moving everything on over at the bottom. Alright, and now I'm going to flip over. I'm going to rewrite that equation so I don't lose it. ES. I'm just copying it over. Where'd it go? I'm not going to rewrite it. I have it solved. E, so now I have ES, and then that equals E total plus S over S, and then I have plus K1 plus K2 over 1, and then that is actually our Km, or equation 2. So here's my new equation, and then I have my Km over here. That's equation 2. That was on our other side. Where'd it go? Over here. So that's one of the equations that we knew already, but now we have it. So now I'm going to use the instantaneous rate of change for P. So that's why I'm going to get my dP back involved. dP over dt, that's the instantaneous rate, and then K2 ES. So I used the K2 equation when we found the product. So now I have strange gears, and now I actually have the equation for this. So I'm going to plug it in while using my, I'm not going to use the Km, but that is Km. So now I have dP over dt equals, and then I have my K2, and then I'm going to plug in my new equation. So I have ET plus S over S plus K1 plus K2 over 1, which is also the Km. So I could have read it with Km, but I'm not going to. But I will circle it and acknowledge that's Km. So now I have my new equation here, and now we have something else that I recognize. I see this K2 and the ET, and that's actually the Vmax, and that's our equation 3. So I'm going to do a big circle here. Vmax, or equation 3. So I circled that. That's actually, here it is, our equation 3. Vmax equals K2 E total, and that's what I have on my other side. So now I have that, and then now we want the maximum rate of velocity. So we have that equation given to us. So we have the V equals Vmax times S over S plus Km. So now I added my Km, and I have my Vmax. So I'm just really rewriting my equation, actually. So this whole equation is the Vmax up here. And now I rewrote it. So I have my Vmax, brought it down here, the S here, S here, plus Km. So that's how you end up finding the max velocity. And then we can use this equation, and then the S's end up canceling out, and we actually figure out that Km equals Vmax over 2. And that is how I derived the equation. So a little maybe fuzzy on it. It was a lot of algebra, but I got the gist. So yeah, that was how I derived it.